This video is going to show you some schematic basics and a little bit about capacitors along the way. So our schematic is a collection of symbols that represent something else, in this case parts of an electrical circuit. So I've got the wires. The wires are just lines drawn on the page. Anywhere where you have more than two wires connecting, like on these diagrams, that's a junction. So right there is a junction, right there's a junction, and a junction. Some people confuse this with a junction, but it's not, because it's not more than two wires. It is two wires. They could be connected, or it could be one wire that's just bent at 90 degrees, but not a junction. Junctions are important because when we analyze compound circuits, we need to know where the junctions are to figure out how the current flows and how to break up the circuit. Positive voltage. On a diagram, we got to indicate where the energy is high. In other words, where it's got the most amount of voltage, because voltage is how we measure energy. So 9 volts, 12 volts. A circle with a line continuing onto the circuit is how we measure that. Now we could also use a battery. A symbol for the battery is this line with the 90-degree lines short and long on it. We need some way on a symbol to recognize as being the positive side, and that's here where the red just flashed. So those red lines are now positive. Now you don't color them red, they're just red in the video. So the red side is positive and the short side is negative. So long side is positive, short side is negative. And you can see the long side I highlighted with the red. Symbols for ground. So we've got positive voltage or high energy. Now we need low energy because current flows from high energy to low energy. So here's our symbol for ground. I've got on the battery, it's the negative side. We're going to call that the ground. And I've got the triangle and the classical lines that get shorter and shorter, kind of in the shape of a triangle. Ground means they're all connected. Ground also means it's 0 volts by definition. So that's where all the energy is flowing to, from high energy to low energy. The symbol for a capacitor, it's a wire. And then because a capacitor is made with two parallel plates, two parallel lines, and then another wire going off to the rest of the circuit. Now to understand part of the circuit, there's a little thing that helps, and that's to understand about the voltage. Every component in the circuit, and you can see I got 3 here that are drawn differently, they all use up a different amount of voltage. So if I start with 10 volts, the circuit might use something like 2 volts, lead me to the green line, which is now at 8. 10 minus 2 is 8. The next one might use 5 volts to the orange line. So 8 minus the 5 volts it uses leaves 3 for the orange line. And the bottom one's connected to ground, so that means it's 0. Therefore, the change in the voltage of the last component, delta V3, is going to be 3 minus 0, or 3 volts. So that's how much energy that one's using. So every component uses up the voltage or changes the voltage in the wires, and that's important for us. 3 basic types of circuits: a series, parallel, and then a compound, which is made up of some combination of the two. So let's start looking at the circuits. To begin with, these are all in series. Series means one after another. TV series, mini series, world series, these are all events that happen one after another. So these capacitors are in series, and they occur one after another as you trace the wire down. The other thing about this is there are no junctions in between the capacitors. So in the left-hand circuit, I've got 3 capacitors in series. If I add a 4th capacitor off to the side like this, what I've just done is I created a junction, and that violates our rule. Series are one after another and no junctions in between the combination. So in this case, it's broken my circuit up into 2 pieces. One part has the series combination at the top, and the other part is something else. So those are all our capacitors in series, and they're and another nice little idea about this is they exist between the junctions and the endpoints. That is the high and low voltage. All right, parallel. So capacitors in parallel, some of these look like they're parallel, but that's not why they're called parallel. They're called parallel because they each use up the same amount of voltage. So they use up the same amount of voltage, and they're connected to the same wire that uses up those voltages. So to begin with, I'll show you a little result of this and a kind of rule to help identify things that are in parallel. So I'm going to look at the middle circuit, and I'll put my finger on one side of one of the capacitors that I think is in parallel, and I'm going to trace the path. So here I am tracing the path, going over, going down, going up, and then back over. Now if things are in parallel, what should happen is I should trace both sides of every capacitor without crossing something that I think is in parallel, or not in parallel. Sorry. So let me show you. Here's the other side of the capacitors, colored a different wire, going up, down, over, and then up. Exactly. So all 3 of these are in parallel. Now, let me show you what happens when I take them out of parallel and put something else in there. So they're all in parallel. I'm going to add a capacitor. It's green. And now I'm going to try the same rule. I'm going to trace the path. So I'll start with this one, this capacitor, and trace the path over. Very good. So now they all connect on one side, but now I've got to connect the other side without crossing another component. So I'll go up and over and down to the capacitor, and then over and down. Yep, that's a problem. So I've got two capacitors that are in parallel, but these other two, they don't connect on both sides of the capacitors, so they're not in parallel. From our previous stuff, you can see they're in series, but we're not going to deal with all that right now. We're just looking for parallel. So these are in parallel. The ones I just added, the green and the black, they're not anything right now, just for the parallel. So let's test your skills.